probably review for a lot of you. You're going to have flashbacks to grade 9, grade 8. But trust me, we're going a different direction later on. So just maybe you didn't catch it in grade 8 or grade 9. Maybe now is going to be your time. It's like you're old enough to be like, you know what, I want to do this. I want to understand it. So let's try our best here. So the first joke here, an invisible sneeze droplet can contain 200 million germs, right? And then you read the hand sanitizer, what does it say all the time? It kills 99.99% of germs, right? And so this person then does the math. This is 200 million times 0.01%. Why 0.01%? Because, right, if it kills this many, then it will not kill 0.01%, okay? So let's do the math there. What's 0.01%? Every time, folks, every time you see a percent in anywhere in this unit, you will divide it by 100, correct? So 0.01% is really 0.0001. That's what it is as a decimal, okay? So if you multiply that by 200 million, let me get my zeros right. So 3, 6, yeah, we're good. So that means that 20,000 germs are still alive, right? Hence, ew, right? So you think, oh, 99.9%, that's pretty good, right? It still doesn't kill everything. So I think it's just for legal. I think it's just for legal purposes that companies have to state it like this. Because if they said 100% and even one survives, I bet you someone out there is going to sue them. I bet you. So anyways, that's that. The second joke here, Dumb and Dumber. I don't know if you watched that movie. It's an old movie. I found it funny.
This was a Rickroll when he did like the
This takes you back to the clip explaining this scenario. So anyways, this is Lloyd. There's Lloyd and Harry. And they're really obsessed with this lady. They found her luggage, and they try to get it back to her. And he's in love with, they both are in love with her, but he's like, here's your luggage, right? Like, you think we can, like, be a couple? And she's like, no, the chances are not good. And he's like, you mean not good, like 1 over 100? And she's like, well, I'd say more like 1 in a million. And so he's like all happy because like, so you're saying there's a chance? So that's the joke there, and he has no chance, by the way. Way out of her league. But anyways, let's do some math. Page 2. Probability can be stated in 4 ways. It can be stated as a fraction. It can be stated as a decimal, percentage, and words. I will say this, please stick to fractions if at all possible, unless the question asks you to state it in any other format, okay? Right off the bat, I'm gonna tell you that. So this is where it gets a little annoying, okay? So when you see 1 out of 3 and you're asked to write it as a decimal, what I want you to do is this, 1 divided by 3, right? You divide it like that. On your calculator, you see this, you write down as many 3s as you can possibly fit, and then you go dot, 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 okay? So what you want to do is you want to look at your screen. This is what you see on your screen, okay? And you want to cut it. How many decimals? That's the standard. It's 2 decimals, correct? So you would take this and literally cut it right there, and you look at the third value. It doesn't affect the second, right? So this would simply be 0.33. That would be the answer as a decimal. Okay? Percentage. Pay close attention to this. You do not take this number, multiply it by 100 to get your answer here. You go back to your screen, you multiply that by 100. So let's go ahead and multiply whatever's on our screen by 100. And you write that number down to 2 decimals. What will it be? 33.33%. That is the correct way of stating percentage. Okay? It's not 33%. Okay, so some folks would take this and just multiply by 100, it's 33%. You would lose round, that's a rounding error. Okay, so you've got to be careful there. Words is I would say fairly easy, just read your fraction. 1 out of 10. You can also, this is cheating here, I think, but it's still acceptable. 1 out of 10. Okay?
Yeah, you say words thing.
The province would accept that. Okay, so if this is easier for you, just go for it, right? Because what if it's 1 over 355,000, right? Then you have to literally write that out. You don't want to do that, right? So anyways, so that's this here is very important, right? That you multiply what's on your screen by 100 to get your percentage answer. All right, let's try that one more time. So you're asked to state the probability as a fraction. You want that as a decimal. You grab your calculator, you go 2 divided by 7. That is 0.25871, and that keeps going. That's what's on our screen, okay? Don't write that down as your final answer. That's not correct. Let me zoom in a little bit. You guys are probably squinting there. So, you take this one, you literally want to cut it right there. So it's 0.2 what? That 5 gets bumped because there's an 8 here. So that'd be 2.6. Oops. Sorry. Yeah. Time to retire. And then when you want the percentage, you take this and multiply that by 100. And then you round to 2 decimals. Okay? That'd be 28.57. Sorry. I think I'm off here, right? Let me try this again. Sorry. 28. So that would be, yeah, I see what I did here. Sorry, guys. And it's on the video, and I can't undo it. Anyways, it's 2857. My bad. 2857. I won't. It is what it is. Sorry, YouTubers. It's okay. So this would be 0.29. My bad. So when you multiply this by 100, you get 28.57. Okay, 28.57% is what it would be as a percentage. Okay, not 29%. You go back to your screen, multiply that by 100, and then round that to 2. Words would be 2 out of 7. That's it. Words are rare. I haven't seen actually on an exam them asking you to state it in words. Yeah.
Why is this 2 out of 7, but the top one is 1 out of 10?
I don't get it.
I need to go home, guys. I need to go home. Sorry, guys. It's 1 out of
3.
Thank you. Yeah. Okay, reset. I need to reboot my computer here. Thanks for bringing that up. And this is 2 out of 7.
Yeah.
Anything else I did wrong?
No.
Okay. I'm just letting you know that I'm a human being, right? That's what I'm doing here. Yeah, I think I'm too tired. Anyways. I've marked too many numbers. Okay, here we go. What about converting between the 3 formats? What if we had fraction, decimal, percentage, and I asked you to go and fill in the rest? Okay? Here we start with decimal. If you wanted to take this to the percentage column here, what would we do with it? Just multiply that by 100. And that would give us 19.2%. Yeah, that's it. 19.2, 19.20, it's up to you. When it comes to anything other than money, we don't have to have 2 decimals if it's a 0 at the end there, right? What if this is probably harder. I don't know what's the last time that you've done this one. How do you go from a decimal to a fraction? This is my cheat for you, okay? Here we go. You write down all the numbers past the decimal. So that's 192, correct? So you go 192. At the bottom, you're going to go 1 followed by 3 zeros because it's a 3-digit number. So you're going to go like that. Okay? 3 digits, 3 zeros. 3 digits. Therefore, 3 zeros. I don't know if you remember that one. And we're not going to simplify fractions. Every once in a while I'll ask you to simplify, but I won't do that on a regular basis. I won't give you marks for it. And this is why. You all have a calculator. Most of you know how to simplify a fraction. Like your calculator can do that just like that. And so I don't want to give marks for that. The province doesn't give marks for it either. I think it's a good skill to simplify fractions, but we're not going to dwell on it too much. Okay, so that was example number 1. What about percentage? If you're all the way on this side, I would go to the middle to get your decimal, then go to your fraction. That's how I would go backwards that way. So I'm going to go this way. Instead of multiplying by 100, guess what? I'm going to divide by 100. So you take the 35.75, divide it by 100, and you write down all decimals here. That is your decimal answer. Then we go from there to fractions. You write down all of those numbers there. So it's 35, 75. In the denominator, you'll start with a 1 and then just have 4 zeros. Yeah. And if you're not sure, just do 3575 divided by 10,000. Right? It should take you back to this. If it doesn't, then obviously you're off, right? Something went wrong. Okay. This one is, you're going to see this on ACs, on quizzes, on tests, right? Like, not like a full table like that, maybe just 2 rows, but I would expect you to know how to fill this in. Fraction to decimal, I think we've done that so far, so let's just fill that in. 185 divided by 237. That's 0.78. You know what I'm going to do here? If you want to do this, I'll never take marks off because this is if you round it to 4 decimals, it's 7806 because that 9 bumps that to a 6. And so what you can do from there to percentage, you just multiply that number by 100 and it's 78.06%. So you can kind of let go of your screen if you round to 4 decimals here. In fact, a lot of my keys you'll see me rounding to 4 decimals when I turn my fraction into a decimal, and that's totally fine. Okay. What about the middle here?
That's the same thing as the first one.
Right. So it's 1, 2, 3, 4 over 1 followed by 4 zeros. Yeah, right. We go that way, and then to go this way, you just multiply that by 100, and that's 12.34%. So I hope this was a good review for you. It's critical. You know what? On the exam, on the provincial exam, one of the questions was, here's the probability as a fraction, turn it into a decimal, 1 mark. I'm like, really? That's it? You got a mark for that? Yep. So if you just know how to do that, you're in good shape. All right, keep going. Simplifying fractions on page 3, I'm going to leave that for now. We're going to go straight to page 4, a deck of cards. So here's where you need to pay attention. I once gave you like a nice colored, it's not colored, but close, black and white. This is a deck of cards. You need to make sure that a standard deck of cards does not include jokers, so we don't have those. So if you just consider a standard deck of cards, it's 52 cards in total. Okay. We've got 26 black cards, 26 red cards. So technically, if you want to cut this deck in half, that's normally, right? we know that all of these are reds and all of those are blacks. Okay? And then every suit, every single suit, right? You've got your clubs and your spades. Those are black suits, right? So 13 clubs, 13 spades. And so you've got your ace followed by 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you've got your jack, queen, king. If you forget that, please write it down here. Jack, queen, king. Write it down at the top. And these obviously are your ace, right? Ace is at the front. That's kind of like our number 1. What numbers 2 all the way to 10? Okay, numbers 2 to 10 are numbered cards. Numbered cards. Anything in here, anything that has a 2, 3, 4, 5, 6 all the way to 10 would be considered a numbered card. What about the jack, queen, and king? So if you wanted to refer to all of these cards here, look at where my highlighter is. All of these ones are called face cards. Those are actually 12. There's 12 face cards. If there are 12 face cards, what would the rest, how many are there that are non-face cards? If you have 52 total, minus 12, that leaves you with 40 cards that are not faces. There's no face in here, okay? I know this is overwhelming, and I wouldn't expect you to memorize this. So here's my way of summarizing this for your study sheet. Got it? So I'm going to do this right underneath. We have no actual card deck of cards because you're not going to get it. I'm just going to do it like this, okay? I'm going to call this deck of cards. Have this somewhere on your study sheet, okay? I'll try to make it very small. Well, for you, I'm going to make it larger here, but you're going to have to compress this. So there's 52 cards, and then I break it down like this. 26 are black, 26 are red, okay? So I break down the 52 into 26 and 26. So sometimes that's all it's asking. What's the probability of drawing a red card? What's the probability of drawing a black card? That's it. You would just need to know the difference here. Within the black cards, you've got 13 clubs, 13 spades. Within the red deck, or red cards, you've got 13 hearts. I would just go C and S on my study sheet because I would know what that stands for. But you may have to write down clubs and spades. 13 hearts, 13 diamonds. Okay, so that's the breakdown here. So if a question asked you, what's the probability of just drawing a club card? You would say 13 out of how many are there in total? 52, right? What's the probability of drawing a heart? 13 out of 52. So when it's talking about actual suits, right? These are our suits. Maybe I'll just write that down underneath. 4 suits. If you need to have that. And then every one of them breaks down again. Okay? Let me try this here. So clubs has an ace, numbers 2 to 10, and then you've got your jack, queen, king. Same with spades. Ace, 2 to 10, jack, queen, king. And some of you might not even need to do this because you know this is the same for every single. This is study sheet entry. And under, like, I'll extend this line here, and I'll just say that there are 12 faces. Write down 12 faces down here. And I might highlight this so you can see it. Face cards. How many aces does a deck have? I think that I wouldn't have to write down, right? There's 4. There's 4 2s, 4 3s, 4 4s, and so forth. Okay? 4 10s, and the list goes on. Please add this to your study sheet because I will have several ACs that refer to a deck of cards. You're going to ask me, can I open my booklet? And I'll say it should be on your study sheet. Okay? Make it small. Like, I made a smaller version on this, on my original here. This is what it could look like, maybe even smaller than that. I think you could probably do smaller than that, but nevertheless, make sure you understand that. Okay, let's keep going. So I have to pre-teach a lot before we actually start doing probability. Go to page 5. I don't need you to freak out now for notation. Notation isn't going to be such a big deal for us down the road. Not in this unit. Probability. What is it really? It's the likelihood of an event happening. Usually we state probability as a fraction. That's usually our first go-to. That's how we keep it. Okay? And here is the probability as a formula. It's not on your formula sheet, so add it to your study sheet. Probability of, you name it, whichever event you're talking about. Probability of, the Bombers winning, probability of the Jets winning, probability of it raining, you name it. We will have something in here. It has nothing to do with numbers, it just tells us what we're finding the probability for, okay? So don't freak out over this bracket. It says number of favorable outcomes. So number of instances where it would be happening over number of total possible outcomes. That's usually what we're after, okay? So favorable is the key there, over total. Remember that. Favorable, it's in favor of what you want. Okay. Probability of it snowing, right? Sometimes it's 40%. So that would be probability of snow. We would actually just come up with 40% here. We wouldn't have it as a fraction, but we can turn it into a fraction if we wanted to. So that's concept number 1. Another key concept. Please don't freak out on this one. Okay, I'm a little nerdy on some of the notation. But please understand this part right here. It's a concept I need you to understand. Let's see if you can follow my train of thought here. I'm saying here, and this is how we deal with everything in this unit. You ready? Probability of an event happening plus the probability of the event not happening is always going to be 100% or 1. So the nerd in me, right? Probability of the event happening plus the probability of the event. What's the E with the little bar on top? Yes, remember that. Okay? Probability of the event not happening is 100% or 1. Mr. Dirksen, why are you saying percent or 1? Well, it depends. If you're adding percentages, you would want it to be 100. If you're adding decimals, you would want it to be 1. Okay? Let's see if you follow my train of thought. Probability of it raining tomorrow, let's say it's 60%. What would be the probability of it not raining, therefore? If 60% of raining, then it's 40% of it not raining, correct? Oh, yeah. So technically, when somebody gives you a probability, you know the not, right? You know what it is not. So if I said The probability of me being sick tomorrow is 90%. The probability of me not being sick is 10%. Right? So that's how probability works. That's what this whole mumbo jumbo is trying to say here. So don't freak out too much about this. I will not expect you to write it out like that. Okay, I just need you to understand. Okay, and then you know what? I'm just going to explain this. So the probability of the event happening would be 1 minus the probability of it not happening. So if you subtracted not happening from 1, you would get the probability of it happening, and vice versa. If you wanted to know the probability of something not happening, you would just take away the probability of it happening from 1 to get that. So if I lost you there, don't worry about it. That's going to be fine. You're going to be totally fine. Okay. This is another thing here. A fair game has a probability of winning of 50%. We would consider that a fair game, 50-50. You could win, you could lose. If there's 0% chance of winning, that would be an impossible, that would be impossible to win. And if there's a 100% chance of winning, obviously we would say it's certain that you're going to win. So sometimes this is going to show up. I think it's just important for you to know that. A fair game is 50%. That's the most important concept here. All right, let's do some math. You know what? Probability actually doesn't take long to answer. That's the nice thing. It's kind of like precision in that sense. Okay, so total provided on this one. There are 20 students in Mr. D's class. Okay, he knows that 7 of those students drive a car to school. Okay, state the probability of a random student driving to school. Fraction, decimal, percent. Okay, so probability of driving, you can write in whatever you feel like in that bracket. When you answer, you tell me whatever you want on there. So that would be what? 7 drive out of my total is 20. That would be it as a fraction. We're done. Now decimal. Grab your calculator. 7 divided by 20. 0.35. Not too bad. We're just going to leave it like that. Percentage, you multiply that by 100, you get 35%. And we literally multiplied this by 100. I should be careful, because then I don't want you to do it if it's more than 2 decimals. So I'm just going to leave it like that for now. But there it is. So 7 out of 20 drive, that is 0.35, or the equivalent of 35%. B, state the probability of a random student, it has to say that, random, otherwise it's not true probability, of not driving to school. Show 2 ways of determining this. So we're going to go like this, probability, driving. If you want to impress me, you'll use this one. Okay? You just put a bar on top and then it's not. What would it be if you look at it? If 7 out of 20 drive, then 13 out of 20 do not drive, correct? If 0.35 drive, then I'm going to go like this, 1 minus 0.35. I'm going to subtract that from 1. That's 0.65. Mr. Dirksen, could I have gone 13 divided by 20? Absolutely. Watch. 13 divided by 20, 0.65. Still works. And that's 65%. What do those two add up to? Watch. Right? Driving, not driving, 100%. Okay. That is something we would want to see if we're asking for not. Right? It happening, it not happening. So, or, this is the other way of doing it, probability of not driving, you could have simply gone 1 minus 0.35, and that's 0.65. Done. Or 65%. So that would have been using the property of not, right? Like that you just subtracted from 1 or 100. Probability, yeah, anyways. I think hopefully you're starting to get that point. Let's go to page 6. I'm almost ready to let you do some work here. This is an example on page 6 where the total needs to be determined. Okay? You need to figure it out. They'll give you individual pieces, they'll give you a diagram, you name it. Okay? Consider the spinners. Spinners are very, very popular, folks. Spinners, deck of cards, dice, popular, very popular. The spinner below state the following, fraction, decimal, percent. Please, on these ones, be very careful. You might think it's the same one. I change it all the time. Okay, I change the number of sections. I change the order that they're in, the number of reds and blues. All of that I change all the time. Okay, so let's figure out our total first and foremost. You do a check mark on the first one. So 1, 2, 3, 4, 5, 6, 7, 8. 8 sections. This is probably the most important piece for you to get probability right. You need to find, like, what are we talking about in total, right? 8 in this case. So probability of drawing or of the spinner landing on red would be something out of 8. We know it's something out of 8. In fact, we can probably go to all the questions and go out of 8, out of 8, out of 8, right? What's the problem? How many reds are there? 1, 2, 3. 3 reds. So 3 reds out of 8 total. You don't have to do this down the road, okay? I'm just doing this for your example. So that'd be 3 over 8. That's good. You go comma, don't go equals because we're rounding. That's 0.375. I multiply whatever's on my screen by 100, and then I write down the percentage. There we go. I'll let you do some of those. I'll just do D with you real quick. What does this mean? Probability of yellow with the bar? Not yellow, right? Probability not yellow. That's what that is saying. How would you do that? It's still going to be out of 8. Can I tell you what the best way of doing not is? Subtract. So I will go 8 minus, how many are yellow here? Just 1. So I'm going to say, well, if I don't want yellow, right, it says not yellow, so it's 8 minus 1. So really you have 7 out of 8 sections that are not yellow. Then you go 7 divided by 8, 0.875. That is 87.5%. So not, try to do minus. Okay? I'll just leave it like that. One more, F, and then I'll let you do, I just want to give you a few minutes, seconds maybe, to do the rest here. What is probability of green or yellow? What happens when you have or? Go to F here. Or means plus. Okay? So you would go, it's still out of 8. So how many greens do you have? There's 1, 2. 2 green sections. Plus, there's 1 yellow section, correct? So it's as if you're saying, yeah, there are 3 favorable outcomes, 3 that would meet the criteria out of 8. And I'm just going to go cheat and then go grab the answer, and A is 3 out of 8 as well. So if you did that right, then you can just copy that and just get that. So I'm asking you to do all 3 formats, but please don't do it unless I ask you like on a test or exam. Because if you get those wrong, you will lose marks. So just leave it as a fraction, you're good to go. So can I ask you to do the rest here real quick? B, C, E, and G. And we'll continue a little bit more. And then I think you're ready to fly solo. Okay? So for just a bit, follow here. Probability of yellow, I would get 1 out of 8, okay? So it's just simply one favorable outcome. Yellow, there's only one out of total, which is 8. That's 0.125, which is 12.5%. Okay, probability of blue, we have 8 total, and we've got 2 blue sections, right? Hey, can you simplify that? 2 out of 8 is 1 out of 4. Just saying, if you can, if you see it, you do it, right? So that's 25%. E, probability of not red. So watch how I do this one. It's 8 total. You can either go count how many non-red sections there are, or you can say, I'm going to take from my total and subtract how many reds I have. And in this case, there are 3. Okay? 3 red section, 3 reds. So that leaves you with 5 out of 8. Do I have a 5 out of 8 anywhere? Not yet. So that would be 0.625 if you do this on your calculator, and it's 62.5%. Okay? Maybe I should highlight the nots, right? So not red, so I subtract the red. Not yellow, I subtract the yellow. Right? So that's, honestly, that's the easiest way to do knots, right? Probability of blue or red, we still have 8 total. We've got 2 blues and 3 reds, so that's 5 out of 8. I'm going to borrow my answer from up here. There we go. And so that's kind of what I'm looking for. So this is a spinner example. Let's try this. This is the last concept, guys, okay? And then I'm going to ask you to try on your own. So making predictions. That is very important. Make sure you highlight that one. So I'm going to use a different color. And I will actually highlight this box because it's not on your formula sheet. But you must know how to do this. Okay? Making predictions. I don't know if do you remember the word extrapolating? You're going extra, you're predicting, you're going what's going to happen down the road. You're forecasting, okay, on a greater scale. So you take the probability of the event and you multiply it by the greater sample size. So this is what I'm trying to say here. If you were to spin the spinner above 350 times, how many times would it land on yellow? Okay, so prediction, we would go probability of yellow multiplied by large sample. What's the probability of it landing on yellow? We already did that up there. Please use the fraction if at all possible. It's 1 out of 8, correct? You multiply that by, in this case, spinning it 350 times. I need you to understand this part. If you spun it 8 times, right, we would expect it to land on yellow 1 time. Okay? That's what this is saying. But we're going to say, well, what if you do this 350 times? So we have to multiply this by 350 to get the larger sample. Okay? So this is how you do it. You grab your calculator. You go 1 divided by 8. I hit equals at that point. Then I multiply it by whatever that, it could have been 1,000 times, 2,000 times. It says 43.75. Can we answer that? We cannot have it like that. That needs to be rounded to the whole number. So that's approximately 43 or 44 times. That's what we would expect to happen on a larger scale. So this is the probability of the event, 1/8, and this is the larger sample. Okay? If the wheel was spun 199 times, how many times would it land on red? Okay? So you go prediction probability of red times large sample. Probability of red is 3/8, correct? I'm going from the top there and just borrowing my answers. So 3/8 times 199 times. So you go 3 divided by 8 times 199. That's 74.625. So that is approximately 74 or 75 times. The province would accept either one. You can't see that, can you? There we go. 74 or 75 times. All right. You go with the rounding that you were taught, right? The nearest whole, this would technically be 75, but the province would accept either one. Okay. I'm going to ask you to do pages 7. Hold on. We're going to go 7 to 14 for today. I wouldn't expect you to finish everything in class, but so try that. I'm going to come around after you've got started.